All right, Matthew, here we go. We've got 8-4, simplifying exponential expressions. Oh, this is a little rough today. Uh, I can tell that I don't want to work today because I was uploading my last video and then I started watching YouTube and I was like watching some guys review a Megadeth song that I like. And then like 45 minutes later, all of a sudden I was watching like marching bands. I'm like, how did I get here? So let's just do this so I can go home finally for the weekend. So here we go. Simplifying exponential expressions. Our question is, how are exponential form and radical form similar to each other? Which form is easier to perform operations with? Exponential form. All right, so fill in the blank. So we've got x to the fifth times x to the blank equals x to the 10th. So this is multiplication. So that must mean that I'm going to add 5 plus something else plus the box, and that's what's going to give me x to the 10th. So that box must be 5, because 5 plus 5 is 10. So my answer is 5. Next one. Again, this is multiplication. So this is m to the whatever that is plus 8 equals m to the fifth. All right, so what plus 8 equals 5? Well, it has to be a negative number because I got to get that 8 smaller. So our answer is negative 3. Over here, okay, ooh, that's tricky. All right, so over here, it's multiplication. So I'm going to add, tricky part right there, 1. So this is going to be t to the 1 plus whatever's in that box. But on the other side, we have to remember that 1 over t to the third is t to the negative 3. So I've got 1 plus something equals negative 3 over there. So this box must be negative 4. Because 1 minus 4 is negative 3. That was pretty tricky, not going to lie. All right, this one. I've got 6, and this is division. So I should subtract whatever's in that box. Equals 9. So how do I subtract and get bigger? Well, I subtract a negative number. So this is like saying 6 minus like x equals 9. So if I subtract 6 from both sides, I get negative x equals 3, and then divide by negative 1, and I get x equals negative 3. So this number must be negative 3, because 6 minus negative 3 is 6 plus 3, and that would be 9. Okay, all right, moving on. All right, so like I said before, it's probably easier to do operations when you have your problems in exponential form. These two are in radical form, so let's change them. Let's change this to 11 to the 1/3 power. And we'll change this other one to 11 to the 3/4 power. And it's equal to 11 to the x over 3 power. All right. Why did I do this? This is 4/3. See, I really want to go home. Really want to. All right, so we've got 1/3 and 4/3. It's multiplication, so I should be adding those together. So this is 11 to the 1/3 plus 4/3. 1/3 plus 4/3 is 11 to the 5/3. So what should x be? It should be 5. So x is 5. Next, I want to switch this one first. It's 7 to the 2/5 power. And then times 7 to the 8/5 power. All right, so this is multiplication, so I should be adding these together. So 7 to the 10/5, because I'm going to add 2/5 plus 8/5. And that ends up with 7 to the 10/5. And 10 over 5 reduces to 7 to the 2nd. So what should x be? x should be 2. And I'm getting really sloppy with my writing. So x is 2. Next. Again, we're going to change this one down here. So 5 to the 3/4 over 5 to the 3/2, right? Because if there's no index, it's 2. All right, so I want to see what's 5 to the x over 4. Okay, so on this, I should be subtracting those. So this is 5 to the 3/4 minus 3/2. I can't subtract if I don't have a common denominator. So the common denominator probably should be 4 there. So this would be 5 to the 3/4 minus 6/4, because 3/2 is 6/4. So this becomes 5 to the negative 3/4. So what should x be? We got 5 to the negative 3/4, so x should be negative 3. Fun, fun, fun. All right, you still with me? All right, here we go. Oops, page is going away. All right, next one. We're going to simplify this one. So let's go ahead and simplify the numbers on top. So we're going to take 2 to the 3rd power. 2 times 2 times 2, that's 8, because coefficients behave normally. And then this would be x to the 1/2 times 3. So that's x to the 3/2 power. Down here, I'm going to take 16 to the 1/2 power. Remember what that means? That means the square root of 16. And we know that the square root of 16 is 4. So I did this. And then here we're just going to multiply. 1 times 1/2 is 1/2. All right, so now we've got a division problem. We're going to reduce the coefficients. 4 goes into this one once, 4 goes into this one twice. So I end up with 2. And then I'm supposed to subtract those. So I've got 3/2 minus 1/2. 3/2 minus 1/2 is 2/2. So this is 2x to the 2/2 power, and 2 over 2 is just 1. So our answer is 2x. Almost there. We got 2 more. All right, next one. All right, so we have to do order of operations. So exponents come first. So I can't multiply until I've done this. So I've got to take 3 to the 2nd power, so that's 9. And then remember we multiply here. So 1/4 times 2 over 1. So that'd be 2/4, which is 1/2. Because this, when we multiply it, we get x to the 2 over 4, and then 2 over 4 is 1/2. All right, so now I can multiply by 2x to the 1/2. So 9 times 2, those are my coefficients. They just multiply normally. I get 18. And then this would be x to the 1/2 plus 1/2 because I'm multiplying, so I add my fractions. A half and a half is a whole. So my final answer is 18x. X to the 1st, which is just x. Almost there. Last one. So remember, we want to be in exponential form because radical form, it's hard to perform operations that way. So here we go. I've got 8 to the 7/3. That's going to stay the same. On the bottom, I've got 8 to the 4/6. Now, these are fractions just like any other fraction. You can reduce them. So 4/3 reduces to 2, 4/6 reduces to 2/3. So here I've got 8 to the 7/3 over 8 to the 2/3. Okay, so since this is a division problem, so I just reduced the 4/6 to 2/3. Since this is division, I'm going to do 7/3 minus 2/3. And I end up with 8 to the 5/3. Doesn't say how they want the answer on this one. So this would be the answer in exponential form. And then if they wanted the answer in radical form, of course, we would just change this to the third root, because our index is 3, of 8 to the 5th. Now, we could actually get an answer on this one because it looks like it's going to simplify some more. How do you say? Well, remember, if I take the third root of 8, we do the index first, and then we take it to the 5th power. So the third root of 8, well, 8 is 4 times 2, and 4 is 2 times 2. So we're looking for 3 of a kind, and we have it. We've got 3 of a kind right there. So the third root of 8 is 2. And then we can take it to the 5th power. 2 times 2 times 2 times 2 times 2, 32. Wow. That's a lot of work just to get down to 32. But that's the answer. There we go. Done. Could you have done it a different way? Yes, you could have. You could have, at this point, done this whole thing with 8 to the 7/3 power, and you would have gotten like 128, I think. Probably. And then over here, you would have gotten 4. So 128 divided by 4 is 32. So you could have done it a different way if you wanted to. As long as you use your operations correctly, the order doesn't really matter. That's all I got. I get to go home. See you guys later. Bye-bye.